The purpose of this get-together and Birds of the Feather is to just bring together people that might be trying to model landscape platforms, the natural world. At the Ocean Exploration Trust, we operate deep-sea, remotely operated vehicles. We explore everywhere from 4,000 to 6,000 meters depth. My role here at the conference was presenting on the work that we've done over the last year to apply a deep-sea photogrammetry system that fuses optical sources of information. So it's kind of the equivalent of deep-sea LiDAR. It's called a multi-beam, high-resolution multi-beam, with the deep-sea photogrammetry models, and then place those all in proper geospatial space in 3D. So that you could zoom anywhere on the Earth in the deep sea, which is, I'm sure you've looked at Google Maps and everything is just kind of this amorphous underwater blob where there might be mountains. And for a mountain that we've actually dove on, provide just a tiny little glimpse of very high resolution data from our multi-beam and our ship-based multi-beam, along with a 3D representation using photogrammetry of the dive track, so where the ROV actually saw the seafloor. We regularly record all video from all of the different cameras on the ROV, and the goal of our project was to demonstrate near real time. I realize actually my talk was titled real time. That means something very different at this conference. Near real time photogrammetry modeling where we would take the images that were coming off of the camera system called the wide field camera array, 3 independent cameras. And every 100 images we would actually go up. I would do an alignment, start the process, and actually overlap those models. And by the end of the dive, I would actually merge all of those overlaps to create a unified, sometimes really bad, like this is photogrammetry done good enough, because photogrammetry done right, like yesterday at the talk, there was some guy that was doing really cool 3D scanning with 157 cameras. This, our challenges is really doing photogrammetry underwater where you've got a lot of backscatter and the image quality is absolutely trash compared to everything that you might be able to get surface-wise. So what I wanted to do here is really just to get, raise your hand if you are developing some sort of natural world or landscape. And raise your hand if you're maybe a platform that is hosting or otherwise enhancing graphics that, is there anyone from like the Epic or anything like that from here? Awesome. And is there anyone that's really specializing in stuff like photogrammetry at scale, Gaussian splatting, anything like that, or other visualizations? Yes. So the purpose of this is to hopefully just get together people to talk around a table about the work that they're doing, to be able to connect especially students that might be out there or other labs. My interest in this is really to provide context to our natural world and provide a way to have new learners that are working in STEM, new students that might be going through middle school and high school that otherwise would never watch one of our YouTube videos of a deep sea animal floating through things, but instead might be more attracted and really comfortable in the world of STEAM and downloading. So I'm curious if you raise your hand that you're actually doing active development, I'm going to put you on the spot and maybe ask you to stand up and just introduce what you're doing and why you're trying to do it. And I'll start with you since you're right here.
Yeah, hi, I'm Jan. I already work for Words I Digital, or FX, sorry, now. Obviously, I don't think I can talk much about our development, but we do simulate physical systems, water, plants, the interaction thereof, etc. But I'm sorry, I can't go into internal details. I will refer to last year's SIGGRAPH when it comes to that. But yeah.
What was last year's SIGGRAPH?
Well, they had a lot of Avatar 2 talks on sort of how we simulated water, oceans, that sort of stuff.
Very cool. Yeah. Are you more on the media production side, or?
No, I'm on the R&D side for the simulation of that. So,
Yeah.
So, and I just wanted to see it, sort of explore this space to, sort of branch out a little bit, see what's happening in this space. Yeah.
Very cool. Anyone else? Who else rose their hand? Be honest. Yeah, go ahead.
So I'm working at Ubisoft LaForge, so R&D as well, but for games. So we try to do nice solutions, but we don't have the budget to do it at large, for example. So we try to do something at like 60 FPS, so it's challenging. So yeah, another type of challenge, basically. We try to do oceans, for example.
Yeah.
A periodic ocean that could be controllable by artists. So we have a paper at HPD where we leverage tiling and blending, for example, to cover a large period, like a large surface of ocean with like a small patch, basically. So the type of thing we try to do.
Yeah.
Efficiency plus hard durability.
Cool. Anyone else? Is this how birds of the feather actually happen? Okay, I'm sorry. I'm sitting down and we've got round tables. I really just kind of thought this was a good opportunity. Go ahead. Yeah.
Hi everyone, my name is Midori. I'm working on like a GIS platform of the air pressure. And then like I'm setting up on the ground and the devices all over the Japan I would like to do. And then the tracking the movement of air pressure and then so visualize on the GIS platform. And to prevent tsunami, because Japan is, as you know, it's a little bit dangerous country. So I'd like to track the natural phenomena all over Japan and hopefully all over the world. So I think your theme is really relevant to me, my project. So thank you for a good opportunity.
How about geophysics? Because Japan is also an earthquake country. Using it similar to track geophysical data.
Excuse me? Yeah.
Geophysics, earthquake.
Actually, like I'm belonging into the lab, which is studying like geophysics. So yeah, very interesting area.
Yeah, well, I will piggyback on that. I had a recent project about visualizing mantle convection. I had some collaborators in Canada who generated these millions and millions of years of simulation of mantle convection and plumes and descending slabs and seeing how temperature and all of these different variables sort of correlate with the motion that you see over large time scales. So I'm always interested whatever data people have on more on the graphics, real-time visualization side of things, and I'll work with anyone's data. If you've got data and standard packages, ParaView, whatever SciViz stuff you're working with doesn't suit your needs, get in touch.
What kind of platforms do you do simulations on?
They had a cluster up there, so again, that wasn't me, that was my collaborators generated the data, and they had a grant and just got a bunch of compute time. And cool. Yeah, so I'm more, the stuff I do, I want to be able to do on like laptops, single GPU, real-time interactive. So I'm previously from the games industry.
Yeah.
And so that's always my goal, is to get big data and visualize it fast.
Cool.
Where are you at now?
I'm at Purdue.
Are you at a big community like the equivalent of NCSA at U of I, University of Illinois? What department are you affiliated with?
I'm in computer graphics technology.
Anyone else?
So I'm from college school lines, and basically doing what he's doing, but they're trying to at least start a program that's supporting that kind of work. We have a huge geophysics program that are using our supercomputers, simulating this data. We also have an Earth Observation Center that does the same thing. It's constantly spitting out processing images of the Earth and methane emissions and that kind of thing. They've created an app that's available for people to see that data. And my job is to support those platforms, and yet I know very little about it.
Yeah.
I got a long road ahead of me to learn that.
Well, I'm here to represent my programs. I'm not doing it all myself. As I I'm from the University of Maryland. We're down the road from NASA Goddard, and so we're working with them on visualizing PACE satellite, plankton, aerosols, carbon ecology. So how do we visualize that data? There's a whole NASA program on visualizing ocean data, which is fun. And then working with them on visualizing in VR weather simulation data so that the scientists can track significant weather events through the Lagrangian process, through the weather data. But the most fun one is Cy Keener, who's an artist of ours, who visualizes Arctic data and environmental data, and he sends probes up to the Arctic, and he works on getting probes cheap. So he does Raspberry Pi probes rather than $20,000 probes, and so the Office of Naval Research is funding this artist to do this, and he is currently working to do photogrammetry on the bottom of Arctic ice to figure out what those patterns are.
We'll talk.
Yes,
This
I
is
thought-
yes. Our work is also funded by the Office of Naval Research to develop the camera systems that were used, which is cool.
Yeah, we have a vision researcher who specializes on visualizing vision through murky media.
So we're also from Maryland. I work for the Naval Surface Warfare Center in Carter Rock, Maryland. And as you can imagine, the Navy needs great training simulations for training before sailors go out to sea. And we develop something called PSIM, which is, it used to be known as Periscope Simulator, but now we simulate everything above the ocean surface. And we historically have been on Open SIGGRAPH, which some of you may have heard of, and we had an ocean simulation for that, and as well as models for all the ships and subs and everything. It's mostly used as a sub-trainer. But we're currently modernizing in the Unreal Engine. So we've used an ocean simulation created by a creator called Death Ray, and we basically utilized the code that they had that was open source, and are currently bringing that into a geo-referenced world so that we can, have the entire Earth and be able to go to anywhere on the ocean. The ocean looks really good, but some of the problems that we're running into is like Unreal Engine has things baked into their water body plugin that are like, you can see there's like Fortnite is in there. The Z is locked to up, so when you try to have the Z at a different angle, you get a lot of problems. So we've solved some of those, but we're still continuing to run into issues of getting that ocean to work throughout the world.
Yeah. I would love the person in Unreal Engine that decided that left-hand coordinate frames were a really good idea. When that person is here, just, don't need to raise your hand. Sorry, that's a sore point. We can talk. Yeah.
Hi, I'm Mike McCann. I'm a software engineer at the Monterey Bay Fire Research Institute. And we have a lot of ROVs and autonomous underwater vehicles, and we have our Keystone platform for mapping the seafloor, something called it's a tool sled that mounts on the bottom of a big ROV. And it's the combination of LiDAR, multi-beam sonar, and stereo cameras, and it can fly 50 meters over the seafloor, or even lower if needed. And the platform can tilt so that it can map deep sea smokers and vents. And it's operational. We're collecting a lot of data. I'm on the team that manages the data, tries to make it visualizable. So I work with the Web 3D Consortium on web standards and open standards for building databases and a web viewing of all of that merged data. We're not yet. We're just tipping our toes into texture mapping the imagery on top of the processed terrain data. Our platform that we use is an open source package called MB System. And I've had students, and I like your idea of engaging middle school students, because this is a long-term process to build these systems. And to have big geo-reference databases that work anywhere on the globe, that deals with all of the peculiarities of these globe viewers and gain things we don't consider negative Z values and weird things that oceanographers like to do, like exaggerate the vertical coordinate times 100, so we can see the biology happening. So the open tools, the open specs, the open standards is where we gravitate, and that's why the Web 3D Consortium and its embrace of OGC standards and Chronos standards like GLTF, really help us.
I'll geek out about the camera system that's actually on that embargo sled. So most cameras to actual, or most deep sea bottles to withstand depth have a very linear and symmetrical geometry for that glass dome that's in front of it to press against the titanium, which itself is a tube and deforms differently. But the camera system that they developed so that it's proper stereoscopic with your eyes is two domes, which is very unique, or at least I have not seen a different or that style of camera system. So they had to model the deformity under pressure of how that flat surface with the two domes so that you don't have like a catastrophic implosion, which I did do one of my camera bottles, but we can talk about that. Yeah. Anyone else?
Oh, go ahead.
I'm Abigail. I'm a master's student at Brigham Young University, and we have an underwater robotics simulator, which is kind of funny because we're landlocked. But we're working.
We're all the best oceanographers.
Yeah. The simulator has a lot of vehicle types and sonar types, and we're trying to improve the reel to swim gap, which is so hard for underwater. And so my project is working on like environment generation, and so I'm trying to find like places to start with photogrammetry and all that. So I'm here to learn more.
Sure. Well, I don't have an oceanography project, so I apologize. But so I'm.
We're accepting of all people, whether it's the air or the land or under it.
Sure. I mean, I'm in a landlocked country, so why not? So my name is Juan. I'm a developer support engineer for Autodesk. Normally in media entertainment, but I also do some stuff now in sustainability and cross-discipline. I'm here just to learn and listen and meet people. A lot of my side projects involve the ocean, just because I came from the Philippines. And I'm very curious about kind of like if there are opportunities to work in open source or like work together in certain projects, that sort of thing, or at least or come up with conversations that could be brought up higher in the industry. I'm involved with ACM, SIGGRAPH, and the practitioner career dev stuff, so that's probably why I'm here too.
If you came in a little, is there anybody else?
I was wondering, Dr. Marcia McNutt, she used to be the head of Monterey Bay Aquarium. She's now president of NAS, National Academy of Sciences. I was wondering, what's the situation with funding for oceanography? Is it from NSF or comes from a variety of projects, sources? So then I was just wondering, in any project, funding is an issue.
Yeah.
Roger Penske, the 20-time Indy 500 winner, he says these cars, his team Penske, these cars don't run on fuel, they run on money. It's sponsorship. So I gotta ask you, what is the situation as far as funding, as far as oceanography, and just in general, all this kind of reality, real world simulation, where's this money coming from? ONR, I guess Office of Naval Research is one, and where else?
Well, I'll speak for us at least. So the Ocean Exploration Trust is part of the Ocean Exploration Cooperative Institute, which receives the vast majority of its funding to distribute among partners. We work with WHOI, USM, a bunch of other universities, but it's entirely funded, or almost entirely funded through NOAA's Office of Ocean Exploration. And I'll say from the funding side, it's very interesting because the Office of Ocean Exploration, and exploration is a little different than a lot of the research arms. Like, it's an important distinction because ocean exploration, we are funded to explore. We're not funded with a particular research objectives. We're not people that study undersea volcanoes. We host that research as we go to, I'll say random, but it is a pre-selected but never ever before explored spot. And we will just explore from the bottom to the top and kind of see what we see. But it's a long-winded way of saying that at NOAA it's an interesting spot because NOAA is big satellites, big weather simulation. There's a lot of these really large programs that NOAA Ocean Exploration is kind of a part of. And I know that actually NOAA OE was actually just recently in the presidential budget actually cut very significantly. But that's why we're doing what we're doing. And then yes, the Office of Naval Research, at least personally for the funding that I'm involved in, is really instrumental in allowing us to experiment with different modes of operations with camera systems, hybrid ways of fusing data in our case.
There's also independently wealthy people. They're into exploration. These autonomous cars, there's a $750 billion projected emerging economy by 2027. There are projects involving students to do ROVs, underwater vehicles, autonomous underwater vehicles. Is that all these people, the Ansari X Prize, for vehicles? I mean, Jeff Bezos, Blue Origin, I mean, all these, Richard Branson, they all they're basically needing to satisfy their egos, so they're doing space exploration. Have you found that some of these rich, wealthy people want to do something with the sea? I know the founder of Oracle, he's into sailing, and he's got this huge, what is it, that competition? He's got this huge catamaran, I don't know,
Regatta.
right.
Regatta. Yeah.
So then now you appeal to these rich, wealthy people who want to be adventurers, explore. And there's this other guy, Elon Musk. He wants to be the first interplanetary species. What about getting him interested in? And people have said that underwater is the biggest unknown, is the biggest kept secret as far as exploration.
Yeah.
So I would say all these wealthy people could be attracted and.
I'll say again, just for oceanography, and then maybe we can continue round robin. For oceanography, the Schmidt Ocean Schmidt Institute.
Ocean Institute.
Thank you. This Schmidt Ocean Institute, Eric Schmidt, and through his foundation, actually has a very similar ship with a very similar mission called the Falcor. And in fact, he has a Falcor 2 now, which is a ridiculously awesome, large vessel. That's dedicated to the same thing. And the beautiful thing about what he is doing with the Schmidt Ocean Institute and the Falcor is they do the same mode of actually just hosting scientists for free. This is the other big thing that they are able to do. I know that they just did this awesome photogrammetry thing of the Galapagos Rift and just exciting stuff. Is anyone else working on other simulation platforms or trying to simulate other environments yet? Anyone else? Oh, yeah, Regatta.
Yeah, Regatta guy. Larry Ellison is his name, by the way. But I'm working with some sort of like neurosymbolic techniques, trying to take a lot of procedural generative tools specifically for vegetation, more land stuff, but sea stuff too, and trying to kind of bridge that gap in a lot of ways. It is a very big open source project. I guess that's the thing that we're kind of all in on. But the idea is actually using a lot of these core foundational tools and figuring out how to like move across the layers of hierarchy. Where it's like are you simulating a piece of ivy growing on a stone, or like square kilometers of like nutrient resources like flowing from plant to plant. So it's the kind of stuff we're working on.
Cool.
So as you mentioned procedure generation, I'm a master's student at Drexel. I'm currently doing my master's in digital media. So recently I just worked on a project for procedure generation for landscaping. It was my first time experiencing with my Unreal Engine. So I was doing procedure generation. It looked really fun, and I took this lecture because we were exploring ocean. So I wanted to work on something like oceans as well with the procedure generation stuff, and I definitely want to look into it.
Yeah. In the ocean, at least for the stuff that we're doing, a real challenge is that we are essentially exploring the ocean floor with a flashlight. And the only other way that we actually see anything around us is through this multi-beam technology, acoustic sonar, like it's multiple arrays, but even the resolution of that, forget what the resolution on your sled. It's like at least for ours, it's anywhere, if you're close, 1 centimeter resolution to a half of a meter. So this is nothing compared again to the terrestrial LiDAR. So creating what we're calling, at least for engaging educators, we're super interested in creating what we're calling the inferred experience. So we have our little tiny sliver of light and video that's associated with it in science logs, and then actually allow you to create through procedural generation a fact-based representation of what could be to the left and right to help, well honestly it's actually to help fill out these worlds where otherwise you're just flying along a grid plane or a point cloud of multi-beam data.
Yeah, that's why like whenever we see any games or like any virtual things happening all around us, the water is the only thing which you are like, oh, it doesn't seem that much realistic at one point, and the landscape just seems realistic enough.
Yeah, totally. Yeah.
Hey everyone, I'm Bo. I'm a faculty member at School of Interactive Engineering at Georgia Tech. So I study fluid simulation. I don't have much experience with ocean, but I'm very interested in it. My previous simulations were all focused on relatively smaller land scales compared to ocean. But I did study a lot of, for example, vortex dynamics or the interfacial fluid dynamics. We want to produce different kinds of visual effects for those fluid, smoke, fire, all kinds of fluid simulation using computer graphics. But I hope to extend these interests and techniques to simulate large-scale landscapes like ocean.
Well, I hear themes here. I hear the people that are really doing a lot of great work in simulation at scale. I'm definitely hearing the ocean theme, so Team Ocean. And I would like to pull together other people that might be working on more of the terrestrial and creating more platforms. There's probably like the media and the arts that you might have heard through here in terms of how to use 3D simulation to actually communicate about the world that we live in, whether that's for conservation or raw education about educational standards or anything like that. So I don't want necessarily us to be sitting, just kind of talking as one big group like that. But what I would like to do is maybe we all stand up, and maybe we have team simulation happening over here. If you're simulating fluid dynamics or air or something like that and want to talk to other colleagues and just network, I'm definitely hearing the ocean theme, which I'll take around this table. I really want everyone to just gather together if you have interest to just share where we're at. There's always a lot of duplicated effort in anything that you do, I find at least, in creating the ultimate underwater ROV simulator and visualizing how the ROV or 3D point cloud data. The purpose of this is to at least get us together so that we can all share contacts and hopefully walk away with this with a good solid step forward. So let us gather in different spots as you would. Is this how the other Birds of the Feather sessions are happening?
Yeah, about half and half. Yeah, this is pretty good.
Yeah, terrestrial landscape stuff also, if you're interested. Maybe you should take that over.